we have a basic understanding about linked list data structure. Today we will start about programming with this data structure, and for programming definitely we should consider the Java programming language. So, today linked list structure again have the different type, say single linked list, double linked list, circular linked list. Mainly we will emphasize on in this lecture emphasize on single linked list data structure. So far the programming is concerned. So, the idea is basically how the different operations on a linked list can be implemented. Now, again I just before going to the actual discussion, I want to mention one thing is that there are two ways the linked list can be used in any application development or any program. One, using the custom concept. Custom concept means you can write the code and everything of your own. Another thing is you can use the package. There is a package already we have discussed about that collection framework, Java collection framework, that is defined in java.util package. So, this package provides you lot of functionalities to realize many data structure including linked list data structure. We will cover all aspects, that means programming of your own, also programming with Java collection framework. But first we should start discussing about programming of our own, that means how the data structures, that is the linked list data structures can be implemented in a program. So, today there are two aspects actually. So far the programming with linked list structure is concerned. First we have to define a list. So, a list can be defined. Now, this definition of list includes whatever the methods that we have discussed, namely insertion related, deletion related, then traversing, merging, others can be defined. So, linked list programming for linked list is basically defining a linked list structure and then defining different methods of it. We will discuss about these aspects about linked list structure and then different operation on it. Now, before going to discuss about linked list structure, you can note that there are two things are to be defined properly. The first thing that you have to define is, so for example, this is a linked list. Now, in this linked list, the list itself is a structure, and you can note that this structure includes the different nodes in it. That means, you have to define node and then using all nodes how you can define a linked list structure. So, these are the two things. Now, again whenever we consider about defining a node, there are again two things are to be considered. The first thing is the data and the next is field or link. Link basically the node which will basically link to the next node. Now, so far the data is concerned, the data can be of different types. So, data can be integer, data can be string, data can be user defined object like student or book. Now, here is again problem. So, if you want to write a program that the linked list you want to maintain for integer or for string or for any other user defined data type, then you have to replicate the same program again and again, but for different types. This is, however, is not a good way to solve the problem, but we using Java and particularly using the generic concept that we have already learned at the very beginning of this course, we can have only one realization, one implementation, only one programming. The same programming can take care any type of data. This is definitely is a very good, what is called the good point that the Java programming can provide you. Second thing regarding the link. So, data can be of any type. Now, link. Now, if we consider the link is what? Link is basically is an address to the next node. Now, if we see the address, so address basically is a pointer, actually the concept of pointer, because it basically so if we say this is the link points to the next node, actually this field store address of this node. So, address of a node is basically pointer. So, what we can say in other word is that this field store the address of a node. So, address means pointer. So, this field will store a pointer. Now, again in Java there is no concept of pointer. Pointer is possible in C programming or C++ programming, but Java there is no concept of pointer. So, there is again question that how we can have the pointer business in this linked list implementation. Java actually make the pointer concept it very easy. If you define an object, say of type say student. So, student and then one object say declare a x. So, student x semicolon. So, that means you define an object, the name of the object is x and the object is of type student. Now, actually this x is the name of the object, essentially is a reference to an object. What is the reference? Reference is basically a pointer to an object. So, pointer means it is a memory location. So, x essentially is basically a memory location and it is a pointer. So, this way Java can enable you the programming as easy as it is possible, and that is really a very beautiful things in programming, because without any pointer headache that is there in C or C++, you can have the same flavor here in Java. So, we will see exactly how all those things can be done in our programming endeavor. My suggestion here, before going to programming, I will try to give you the programming essence as much as possible, but you know understanding programming needs hands on, what is called the practice, or rather we can say that you should try to understand the code, compile the code, run the program, and then you can understand that what the program is doing. So, merely seeing the program you can understand only 1% of the programming, what is called the benefits, but to have the best, what is called the skill, you definitely have to write the program. And another suggestion is that while you are writing the program, whatever you want to have certain modification, do it and see whether it is working or not. At the worst case, what it will do, either compilation error or runtime error, absolutely not an issue, but by the process you can understand why this error is giving, why this error is coming, why this compilation is not successful, whatever it is there. But idea is that you should try to indulge yourself into the programming, and more programming practice will give you the more edge on the programming. Anyway, so I will give you all the programming ideas that we can think for linked list, and you really enjoy that how such a nice things can be done using Java programming. And particularly linked list is a very complex one concept, complex data structure, which many programmers scared or fear that okay, oh no, we will not be able to do because so many pointers and everything, and usually end up with the incorrect result or either compilation error or so many things are there. Anyway, so that is, now let us see how the programming can be done. I have already told you two aspects are there. We have to define a linked list. Defining a linked list means you have to define a node first, and then the methods that basically require in order to manipulate the linked list, and this basically following the logic that we have discussed in the last two video lectures in this module. Now, I can give you the framework of this programming. systematically if we follow, then we can understand a lot. Now, first of all, we have to declare a generic class. Why we should declare a generic class? Because our intention that our linked list should store data of any type. Any type in the sense that it is integer, string, or whatever it is there. So, we can say that it should store object of any type. Now, in order to declare a generic, as you already familiar to the generic programming, we can declare a generic, and this T is basically template that it can hold any type of data, the data type T. T can be any type. Then the next part is basically declaring the structure of a node, that is basically for example, single linked list, you have only one data part and then only one link. So, that definition will be something, then the double linked list or some other type of linked list. So, this basically includes how you want to define. For example, data can be again different way you can compose or whatever it is there. So, all these things should be taken care in the first part, is a part 1. And then second part is basically different methods related to insertion, deletion, traversal, printing the list or merging, whatever it is there. So, the different methods can be declared here. Now, this way the entire class can be declared. This is the usual concept of Java programming, the class declaration or class definition, which includes field declarations and the method declarations and method definition, body of the methods. So, this is the basic idea about that we should follow, and let us see how actually our programming for the linked list can be carried out. First, we should discuss about how the field, that means the node, can be defined, and then finally, we will go for discussing about different methods one by one. As the number of contents are high, so we should discuss slowly and not possibly in 2 lectures videos, the current one and the next one. Now, look at this program. This is a very simple program. You have to look it little bit carefully. I will try to give you the idea about how we have solved this problem. Now, first of all, this is the usual concept that we are declaring a generic class, and T is the generic facility that we can have any type. Now, here node, we declaring node because linked list consists of a node. So, this basically we create the head. This is basically a field that we told that header. There should be a node called the header, which is a dummy node actually, which does not have any data and link. So, this header is itself a node. So, we define node is a basically type. We will discuss the node type right now. So, node and header is also a node. So, basically a linked list is a collection of nodes of type this node. Now, let us define what exactly a node it is. So, we have another inner class declaration. In this inner class declaration, a node is defined by 2 components. One is called the data, and this data is of type T. It can be integer, it can be float, it can be double, it can be string, it can be student, book, like this one. So, we declare the T. So, like this, and then this basically is a link. Next is basically the link to a node. So, that is why type is this one. So, this completes the declaration of a node actually. This is very simple. So, 2 parts, node is defined as a T of type data and then the next field. Now, then in order to create the nodes, and then finally linked list, we should have a constructor. So, that means how a node can be initialized or can be created. So, here in this program we have defined 2 constructors. The first is a default constructors. As you see, it is basically create a node for which the data is also null, next is null, means both the fields are null value. Then another constructor is basically take the argument data, and it basically initialize the data field by this argument passed, and then for the initial creation of the node there is no link. So, we made next as null. So, these are the 2 constructors that can be created, that can be considered while you maintain a linked list. And then here you see, So, this basically gives the declaration about the nodes in this linked list structure. Now, here we want to create a linked list. So, this is about node. Now, what about the list? List is again another object. Now, this object has, these are the fields that we have already declared. Now, here comes to the linked list itself, because how it can be created. So, in order to create a linked list, we again require one constructor. So, here we declare a default constructor, which is very simple in form. Here you see the default constructors, and whenever we create a linked list, initially it contains only one node, namely the header node. So, that is why we create a head already declared as a node type, and new. So, you see we create a default node new, I mean using the default constructor node new, that means header is initially created, for which data is null, and then link field is also null. So, this way you can define the linked list structure, the linked list structure itself, and then the node in it. So, this basically the first part of the part 1, which basically give you how a linked list can be defined. Our next part is basically methods. So, there are different methods can be defined, as many methods you can add into this class declaration. So, like this one. So, here is the idea about different methods that we can think about in this data structure based on our discussion that we had in the last 2 lectures. So, here we have listed the insertion related operations, the traversals, merging and deletion operations. So, we will discuss all operations one by one, and here you can see insertion operations again can be based on different cases. Why different cases? Because for different situation the number of links that needs to be manipulated are not same. If it is at the front, only fewer links; if it is at the end, again fewer links, but if at any position, then few more links, like this one. So, that is why 3 different cases that we had discussed in earlier. Now, we will give you an idea about in the programming, so that if you little bit do the programming bit cleverly, then you can do only one implementation, but taking care of all cases. Definitely this is a clever process, but what actually you should do after implementation, after definition, when you want to run the program, you should test whether your program can satisfy all cases or not. So, that is why we have little bit discussed in a structured way different cases of insertion, deletion or whatever it is there. Now, let us first start with insertion operation in this direction. Now, before going to this each method, so every method should have its own form, it is called the signature. We should decide, because program should be designed very nicely, so that you can systematically write code. So, that is why we have discussed the different codes for that. Now, so for the insertion at front, we have declared this method. Now, you see it is written, it is basically all methods are declared as public, because we want to make the class declaration accessible to any program. That is why if you want to restrict, then you can declare private, protected, whatever it is there. Now, our objective, our intention is not to maintain any access restriction. So, let us make it public. Then, so return type, you see some methods return void, some method return of type, whatever it is there. So, because of the logic it is there, insertion at front does not return anything. So, it is void, and whenever you want to insert it, so you have to pass which data you want to insert. So, data is basically the data of type. So, insert font, like this one, the different method here we have discussed. Now, this is very important, because we follow signatures what we basically planned or designed, so that we have a very robust and then systematic code. Now, so this is about the method signature that we want to implement one by one. first we will start with insertion at front and then insert end, then insert key like. Now, let us come to the insertion operation one by one. As we have already made the discussion is that different cases are there and we have to think about the different cases and how these different cases can be carried out. Let us first go quick recapitulation of each cases and then the code for each method. Now, insertion at front, 3 cases, insertion operation having 3 cases, insert front, insert end, insert k. Let us first discuss about insert front operation. So, it is basically insertion at front. Now, if we check it, insertion at front can face 2 situations. One situation is that we want to insert one new node to a list which does not have any node, it is initially empty. Now, empty list means that it has only the header node. Otherwise, we want to insert a node at the front in a list which contains at least one node in it, one or more node. So, 2 situations. So, these 2 situations are here. This is basically the first situation, that the list is initially empty, and the second situation is that the list contains at least one node. Now, so this insertion if you see is pretty simple. So, this is the node that you have to allocate first, and once the node is allocated, let the name of this node is new node, this is the object. So, what we should do is that the value of this field next should be equals to new node. So, next, so header dot next equals to new node basically makes the pointer to this one. So, this insertion takes place. Now, on the other hand, what the insertion here, it is basically this is the new node and we have to make the first node which basically header points. So, basically header points this temp. So, new node dot next is equals to temp if temp is the address of the next node. So, this basically make the pointer to this one. So, this pointer, and then finally header dot next should be equals to new node. So, this way insertion at front will be taken place. So, now this again the operation should be done. This is the first one, this is the second one, which we have already discussed in the last video lectures, where we have discussed in details about this one. Anyway, so this is the idea about how the insertion at front can be done. Now, let us have the code. The code I will explain you, but you can run again the codes for your own understanding in your own space rather. Now, let us have the code how it will be. So, these are the import is necessary because we want to include util packages. Java.io may not be necessary in this case particularly, but in some situation it may require. So, you can, it is optional right now. So, we are declaring the class linked list. So, this is the name of our linked list class that we have already discussed about that different fields, the copy the code for the declaration of the class which we have already mentioned discussed, and then the method. So, here is the body of the method will look like this. So, public void insert from t data, and then body is basically we are now on the way to write code for this one. So, this basically we are adding our first method to the linked list class declaration. The method is insert front. The method has one argument of type t data. Now, so now let us see what is the body, that is the main part of the method. Now, body is basically considering 2 situations we have discussed. So, let us see how the code will look like. Now, here is the code you see. So, this is the body of the insert at front method. This is the fine. Now, you see node, new node, new node. This basically allocate a node new that you want to insert into this one. So, this is the first is called the allocation. So, allocation means it will get the node from the memory bank. Now, new operator will basically allocate the memory for you. Now, new node dot next if you write this code, what it does mean? Now, head dot next is basically the address of the first node, and this basically is the linked list which we are considering, that is why this node's header. So, this basically new node dot next is basically store the address of the first node in the list. Now, okay, fine, and then we make the header link of the header node as the address of the new node. So, this one. So, the two link operation is there. Now, here you can understand that this will work if the list is initially empty or not even, in the both cases will work for you, because if suppose the list is empty, if it is empty, then head dot next is basically null. So, new node dot next is equals to null, that means this is the last node, and then thus the head dot next will point to the new node. So, it will work. Now, again this will work obviously if the list contains at least one node there also. So, both way you see this code is written in that way, so that it basically works for you for satisfying the both cases, both situation, either the list is empty or list contains at least one node in it. So, this is the beauty that okay, you little bit cleverly we have managed it, so that we can many cases whatever it is there, but compact way it can be. Otherwise, you can have more if statement, more case check statement, and then you can write it, which is unnecessarily code is too lengthy, but this is a very compact code that you can have it. Little bit at the first learning you may find little bit difficult, but whenever you are habituated, this is the first time you are handling with pointers in Java. So, you may little bit feel little bit difficult to understand, but if you go on practicing, and then you will be able to understand it very easily. I hope you have understood. Anyway, in case of your difficulties and everything, definitely you should pose your question to the discussion forum. Now, let us come to the next operation. This operation is insert at end. Again, like insert at font, it has the two situation: the list is empty, there is no node in it, or the list contains one or more node. Now, whatever be the situation, the idea will be like this. So, if the list is empty and if you want to insert at end, the same as this field should be equals to this one. So, that means header dot next is equals to new node, that is all. Or if the list contains at least one element in it, so you should start with header, because this is the only pivot from here you have to start. So, header, and then you have to traverse the entire list, go to the last node. What is the last node? Last node is that node for which this next field is empty. So, you have to just have a loop traversing each node until you can come to a node for which the next field is empty, and let this address of this node and let the name of the address be temp. Once you know this, then adding this new node into this list is very easy. Just simply make this next field is equals to new node. So, this way it will add the node at the end, and definitely you should not forget about making the null field of this new node as null, but whenever you create a new node by new operator, it automatically create a node for you, for which the data can be using the constructor data can be initialized by the value that you passed, and then this one. Now, let us come to the details of the programming having this concept. For this, the code is very similar. What exactly the thing is, you have to add one more method. The name of the method, as you have mentioned, insert end, in order to add a well data of type T, and this basically the method body, and body is to be defined. Now, let us define the body, how it should be. Now, here is the body of the method. The name of the method is insert end. Again, two situations, empty or non-empty, but we can write a compact code the way we have done it for the insert add font, same way, and code you can check how it work. So, first we have to allocate a new node for the data that you have to pass. So, new node. So, new node is the name of the node that we are going to add into the list, and this is okay fine. Whenever you use this constructor, if you see the constructor automatically creates the null link field null, but you can do it also forcefully. That is what we have made, that new node dot next is equals to null. That means, this is the node whose link field is null. Then we create a temporary node temp this dot head initially start, because temp is basically a pointer which basically used to traverse the entire list starting with the head node. So, this basically this is the node and the linked list for which the header is considering. So, this dot head is basically header of the list, and temp is basically point to this header. So, this is the pointer. Now, here this code you can understand what this code will do for you. So, temp dot next, that means we are checking whether we are at the end node or not. So, if temp dot next is equals to null, that means this is the node whose link field is null, then we can say that it is the end fold. If it is not, then we just simply move pointer from one node to the next node. So, how you can move it? This is the way of moving from one node to this one. So, just changing the pointer from the current node to the node which basically store its address into the next field. So, temp dot next is basically temp, that means the pointer is moved from one node to the next node. So, this is the concept that you can follow very easily, and once you reach to the end node, then you just simply make that link of this last node as the new node. Now, again you can check whether two situations, when the list is empty it is working or not. So, this code definitely will work for when the list is not empty. Now, if the list is empty, then what will happen? So, this is fine, no problem, we have created a new node and then we are presently at the header node. Now, whenever the list is empty, then the pointer that it store, the header node is null. So, this loop will not work because this will not roll. So, you will directly come to here. What is the directly means? This is the temp is presently the header node. So, header dot next equals to new node. That means, we just assign the link field of the header node by the address of the new node, and that is work. So, this is the idea about that how the two situations can be accomplished in one way of coding. No need of special checking whether this case or that case or like this one. So, this is about insertion at end. Now, insertion at any. So, in order to insertion operation whenever at any is there. So, there is basically at any means basically we have to check that we want to insert a new node after a node whose value is a given value. So, this given value is called the key value. Now, there are again two situations for this. First is that a key is not present in the list at all, and that list can be again initially empty or it can contains one or more node, whatever be the situation, but key is not present there. And the second situation is that key is present there. Key is present there means definitely it is not that a list is empty, list is non empty and it can contains one or more node. So, this is the concept actually. Now, let us see how we can write the method for insertion at any considering whether key present or not, it is there. If key is not present, then insertion will not do anything. So, it is just simply nothing, but if key is present, a new node will be inserted just after the node whose value data value is key. So, this is the idea about. Here is the pictorial concept that you can see. We have to come to the. So, now starting from header, you have to first go searching that whether there is a node which contains key or not. If it contains, then the which is the node actually it is there. So, we have to come here. So, temp is basically is the node which includes the data value is key in this case, and a new node we have to get it from the memory bank and then node needs to be inserted here. So, insertion is like this, we have to set this pointer, that means which basically points, assign this one and this pointer will be there. So, two links are to be managed, and this way a new node will be added just after the key node. So, this concept can be implemented writing few lines of code, and now we will see exactly how the codes will be there. So, this basically the idea is that we want to declare the method. The next method is basically insert key. For the insert key, this one key, that means this is the value after which the new value, that is the new value, needs to be inserted. Now, let us see the code. The code is again pretty simple like the previous course actually. I will just explain it. This method that we are going to have the body now. So, this basically get the new node, then we initialize that, we have to start from the header, and then status is the one thing that whether we can find node is exist or not. So, now in order to check whether the already node is having which value is basically key value. So, this basically a search is taken place, and the search will basically whenever it finds the key value is present, status will be made true, and then it will break from the loop, because once you find it you no more need to traverse again. So, stop there and come here, and if you find the key value it is there. So, temp equals to temp next, and only so this basically is the code by which you can make the traversal starting from the header node to reach to the node if it is there or not. Now, if key value is not there, then status will be false. So, if status is false, do not do anything, that means key does not present there. So, we do not have to do anything. If key is present there, so that is why if status is true, now you see the node, just link management that I have mentioned, two link. So, new node next will be the temp node, temp dot next, temp is basically where the key is present, and then temp date nodes become the new node that it is there. So, these are the 2 pointers or link to be manipulated, that is all. So, this way insertion at any position can be carried out. Now, you can again check the program, run programs and check whether it is working or not. I will give you a simple master program one, so that you can check whether all methods that we have discussed whether it is working or not. So, this is the this is now let us first going to the master program again. I just want to have one more method want to include it. It is called the print list. Print list means it basically print the entire list. A collection can be printed of course using system.out.println by giving the name of the collection. Now, in this case you see a linked list is basically a collection. Collection means is a collection of elements, where a node in this collection or in this linked list stores an element. Now, let us see first define a print list method going to a master program. Master program basically call the different operations for a given linked list, how a linked list can be created, etc. Now, let us come to the traversal operation first, so that we can have the full idea about it. So, it is a basically traversal operation that we are going to plan is basically to print every node in the list. So, that is why we have given the name is a print list is the method, as it does not require any value to be passed. So, its argument is null and it should not return anything. So, that is why return type is void. We made the method public because any program can use it. Now, so now print list is basically traversing. Traversing means it is just starting from the header node. You have to go to the next node, print the value that the node contains, then move to the next node, and you should continue this till you reach to the end node. End node means the node whose next link field is null. That is the idea actually, very simple idea. Now, let us see how the program for this will look like this. It is basically just simply a traversing, moving the pointer. and how the pointer can be moved from the one node to the next node, it is basically temp equals to temp dot next. This is a very simple procedure. Temp is this one. So, temp dot next means this one. So, temp new temp will be there, that concept it is. Now, this is the code that we are going to write, and here is the code, you can check it, very simple code. So, this is the name of the method. Now, we start as the car node is basically head dot next means the first node. Now, if it is empty, then you stop it there. Now, here you see system dot out dot println linked list, we are going to print the linked list actually, this is a simple message print. While current node not equals to null, if current node equals to null, that means if the list is empty, it will directly come here, nothing will print, list is empty, no need to print anything. But if list is not empty, then it will come here system dot out dot println current node dot data. So, whatever the value that the current node contains, so data field contains whatever the value for the current node, it will print. It can store any value, string, integer, double, or even the student type, where the name, roll number, marks, whatever it is there, because your system dot out print method is very powerful, it can print anything, and anything as the form of a string actually. So, this way absolutely you should not bother about, any value can be, your node can, your linked list can contain any type of value, it can print it, and then once you print the current node, you move to the next node. So, next node is very car node equals to car node dot next. So, move to the next node. So, this way you can traverse from the header node to printing each node in it and then displaying. So, this is the idea about the print method, and so once we are having the insertion operations and print method, we are in a little bit position to have a driver program or master program. So, this is the example of a master program. The master program basically create a linked list according to our program implementation that we have done. We are now in a good position to create a list, and then we can insert element according to our wish, insert at front or insert at any or insert at end, whatever it is there, and then finally printing the list. So, for which what we do, let us check it carefully. So, we are declaring a class is our program, the master program or driver program, which include the main method, and you can see in the earlier declaration there is no main method, only we are busy to define our class. The name of the class is JLinkList, is a generic class, and this class should contain a number of node and how insertion, how printing, traversing can be done. Now, so we first create a linked list of type JLinkList. JLinkList our class declaration. Now, here you see generic, we want to create a list of integer. One thing you should note, you should not write int as a primitive data type, you should declare as a object type. Okay. So, that is why capital integer, that means we want to store integer value, but it is an integer as an object we want to store. Now, this is the name of our list we gave, you can give L, you can give X, no problem, and this basically initially create the node, and for which we call the constructor that is there. So, this constructor will create a list which is initially empty. So, this basically the declaration about how a linked list can be created, and initially the linked list is empty. Once the linked list is created, then we can go on adding node one after another or whatever it is. So, here you see we can call insert end method for this list, and the argument that we pass 9, you can understand what it does mean. It means that we want to insert a value, the value is 9, insert at the end, as the list is empty, absolutely no problem, it will insert anyway, then insert at front. Now, okay, then print list, so it will print the 9 value only. Next, insert front. Now, what you can see is that 9 is there, we want to insert 5 before 9. So, you can do it, and then print, you can it will print 5 and 9. and so on. You can see the different insert operation can be insert end, insert key. That means, here you see we want to insert 7, this is the data after a node which it contains 5. So, basically the 7 will be added there in the node after 5. So, 9, 5, 10, 9, 5, then 7, 10. So, this will be the list. If you print list, call the print list method, it will print 9, 5, 7, 10 like this one. Now, so on, we can go on printing, doing. So, you can just call the method as many times as you wish to increase the list according to this way. So, this way you can learn about whatever the code you have developed so far, you are now very comfortably create a list of your own, and the list is basically will be given or called by a name, and this name as you have given, it is programmer given name, the list you can give any other name also there, and this list basically maintain the header and everything inside this one. So, it is just like a linked list itself, usually it looks like. Okay, so, this is the program so far that we have discussed about insertion operation into a linked list and the different cases of insertion operation. Now, before going to just wrap up these things, let us see the merging operation. So, you know exactly what is the merging operation. It basically append one list after the another list. So, there will be a master list, and then this master list basically should call this method merging, and then as a method it should pass an argument that which list you want to merge into this list. So, now merge method needs to be defined. Now, what is the idea about merge method that we want to discuss about? You see, this is the name of the method is merge. It does not return anything void, and here is basically j linked list t ll. So, basically we have to pass as an argument one list, and this merge method can be called for a list. This means say list 1 and this is the list 2. So, you should call the method merge for the list 1 giving the argument list 2. This means that list 1, list 2 will be appended after list 1. On contrary, if you can have the two lists, list 2 and list 1, and if you call the merge method for list 2 passing the argument as list 1, then here list 1 will be appended after the list 2. So, it is basically whether L1 will be added after L2 or L2 will be added after L1, the way you can call it. Now, here actually the idea is that how the method can be declared and can be defined. So, we have idea about how the method should be declared, what is the signature of the method. Now, let us proceed further to understand the actual code, how it look like. So, this is the signature, that means this is the name of the method, and then body that we are going to write, and the linked list, as you know, very simple, what is called the manipulation of the list. So, we have to come to the first node of the temp. So, that temp 2 should be filled with this one. So, that means temp 1 dot next is equals to temp 2, that means this basically points. So, this way this node will be here merge, but this header node is a problem. So, what we should do, that we should make free this header node. Now, to get a new node, there is a new command is there, new operator is there in Java to make a node free. That means, we want to return to the pool of memory manager or bank, then just free the node. So, free header, this means it will return to the memory manager, memory bank. So, this is basically the idea about. Now, let us see the code, which actually how it look like this. The code is okay. We want to add one more method. This method, we want one more method into the our linked list declaration that is going on. So, this method again we want to add the merge method. Now, code, actually a code, this basically managing the links that we have already mentioned. So, this is the method. L2 we want to append L2 after the call method. Now, here suppose node L1 is the current node. So, this dot head is basically current node, and node L2 head, this basically is the first node of the node L2 which has been passed here. So, you can have the two pointers, one pointer is basically the header of the first node, and then second is the basic first node of the next second list. Now, here you see first we have to go to the last node of the list L1. So, this is a simple traversion because we want to add the list at the end of the last node of the first. So, that is why we have to do it, and then this is the simple link management as I told you. L1 node dot next, this is the last node, as the L2 dot next, this is the first node of the second list, and then we have to make the header free. So, this is the method free, so that we can return the header which is no more required for the second list, return to the memory bank. So, this is a simple idea, and you can note it how interestingly you can write the code and it can work. Now, again you can write the master program and call all these methods there, and then the code will look like this. So, this is another master program which basically exhibit the operations that we have so far added into the linked list. Now, in these methods we see the main we are discussing two lists we are creating, list 1 and list 2, all are of type integer, that you should do. You cannot do in other way, one is integer, one is string, then it will give a compilation error. Then there are different way that we can add. So, this basically creating the first list L1, and then we are also creating the second list, adding some element into it. So, two list is ready. Then we call the merge method for the list 1, passing argument list 2, that means list 2 will be added at the end of list 1, and then printing the list L1, it will basically print after adding. Alternatively, you can call again list 2 dot merge list 1 passing this one. So, it is the opposite way it can. So, this basically the master program, if you run, you will be able to see how the list can be created, two lists can be created, how one list can be added after the another list, and vice versa. So, this is the code that we have think about insertion operations. Now, other operations, namely other traversal operations like reversing and deletion of a node and other operation we will discuss in our next class. I hope you have understood it, but my advice is that you can write the code, practice it, and for code and everything you can follow this link where you can find all codes that we have used here, and then slides and everything you can have this link, so that you can enjoy your reading and learning also. So, this is about the first what is called the phase of programming, first part of the programming, part 1 programming concerning linked list manipulation. In the next we will discuss about other operations related to this. This is the second part of the programming. Thank you very much. Thank you for your attention.